In this class, we're going to take a look at some of the types of function that you get. So when you start working with functions, you learn a few basic rules. You realize that a function is a fancy version of a rule. It takes an input value and it turns it into an output value. So you kind of conceptualize what a function is. But before long, you start to realize that a lot of the functions look quite similar, and basically they belong to different families of functions. So in this class, we're just going to chat a little about some of the families of functions that you get, because as you go further into the study of functions, which eventually will take you through pre-calculus and then into calculus, calculus is essentially the study of functions, but to quite a high level, then you're going to want to have some framework in which to think about those functions so that you can look at a function and say, oh yeah, that belongs to that family. And if nothing else, your math teacher is going to be referring to functions as belonging to trigonometric or exponential or polynomials, all these different families of function. In fact, let's start with those guys, the polynomials. So they're a really important family of functions. They're probably the first ones that you're going to see. I obviously cannot even spell the word, so I'm going to start that again. So polynomials. So this comes from the words poly and nomial, which means multiple powers. So these are functions which are in the form of having different powers. So I'm not going to show you the general polynomial, but I'll give you some specific examples of polynomials. So the first one that you're probably going to meet is what's called a quadratic function. In a quadratic function, the key value is that it's got an x squared term in it. So an example, just write an example, would be something like 2x squared plus 3x minus 4. That's an example of a polynomial. It doesn't have to have all of the powers of x, so power of 2, power of 1, power of 0, but for a quadratic it has to have a power of 2. So another one as an example would be x squared minus 17. That's still a quadratic type of polynomial. So polynomials are defined by their highest power. So the next one after that is called a cubic. So cubics are defined by having an x cubed as the highest power. So an example of a cubic would be something like x cubed plus 4x squared minus 12. That would be a perfectly fine cubic. And then you just move up powers from there. So the next one is a quartic. So probably you've figured out by now that a quartic is going to have a power of 4 as its highest power. So an example of a quartic would be something like x to the 4. There could be a number in here, plus say 3x squared minus x plus 2, something like that. It doesn't have to have the x cubed term. This one didn't have to have an x term. As long as it's got that highest power, then it falls within that family of subtypes of polynomial. So those are all your polynomials, and they just carry on and carry on. When you first start working with functions and polynomials, it'll be these two you'll focus on. You might even use these for 2 or 3 years and hardly ever even see these ones. These are already quite complex types of function. So that's your first family there, the polynomials. Probably the next family you'll learn about are the trigonometric functions. You might have seen these already. If you've already done SOHCAHTOA and the trigonometric ratios, then you'll have seen sine and cos and tan. So there's the sine function, and we've got the cosine function and the tangent function. And these are just to do with turning the angles in a triangle into the side lengths, or a relation at least between the angles and the side lengths. So they're kind of they've got like a geometric interpretation. But there's a whole bunch of other ones as well. So you get something called arcsine, and you get something called arccos, and there's arctan, and you get something called hyperbolic sine, which we write as sin with a h, and hyperbolic cosine, and they carry on and carry on. There's a whole bunch of trigonometric functions, but they've all got some kind of almost geometrical interpretation because they're kind of in a way coming back to triangles. So that's two of the big families of functions that you're going to see early on. And then you'll start to move into different function types. So for example, exponential functions. Exponentials come from the word exponent, and exponent just means power. Another word for power, nomial means power as well. These mean that the variable, the x term in your function for this guy here is in the power. So these look like some number, say 2 to the power of x. Okay, or it could be 5 to the power of x, or it could even be something like 3 to the power of minus x. But the important thing is that the variable term goes in the power for that family of functions. The inverse of an exponential function, the opposite, is a thing called a logarithm. And logarithms and exponentials are generally learnt together. So you usually learn this one and then you learn this one. Logs are kind of weird, to be honest. They've got their own notation. You write things like this. And really, you've kind of got to understand these guys first to then understand logarithms. One of the things we do with functions is to consider the structure of them, but also how we can then start to make graphs that represent them. So being able to look at the graph of a function is really important for being able to learn key information about the function. So for example, the sine graph, let me just draw it here. The sine graph basically is a wavy thing that looks like that. And we can get quite a lot of information about the sine function by looking at its graph. For example, it's got a highest and a lowest point, which never goes above there or below there, and it repeats itself on this cycle forever. So that repetitive nature tells us something about the function. Same for the cosine graph. The cosine graph is the sine graph just shifted over a little, so it looks like that. And then these guys are a more complex version of those guys. These guys are a different version as well. Exponential graphs always go like this, unless they've got a negative power, in which they go the other way. They would go like sort of down like that. So learning all of these forms of the graph starts to tell you things about the functions. For example, this guy never goes underneath the x-axis, so it's always giving you a positive value, and it gets very close to the x-axis as it carries on this way forever. This guy, a logarithm, that goes like that, and it never crosses over the y-axis. So imagine that's the y-axis down that line. Imagine this is the x-axis along this line. So knowing these things about the graphs of these functions starts to tell you things about them. This guy here, a quadratic, that makes a U-shaped graph. This guy, the cubic, makes a graph that looks a little bit like that, but it carries on up and down the way forever. This guy here can make a variety of graphs. Quite often they look something like that. It just goes on and on forever. So there's all of that to learn in the future about these different function types. But all I've tried to do in this class is to give you an overview of some of these big families of functions. There's a whole bunch of others out there, but just remember that regardless of whether it's a quadratic or a sine or an arc cos or an exponential, a function is just a rule, a formula that takes some input value, does something to it, and gives you some output value. So for example here, 2 to the power of x, if I put an input value there of 3, so let's say that we had f of x equals 2 to the power of x, f of 3, well, that's just 2 to the power of 3. 2 to the power of 3 is 2 cubed, which is 8. So I've turned my 3, my input value, into 8, which is the output value. So I've given that function a value, 3, it's taken that in, it's done something to it, it's cubed it in this case, turned it into 8. That's all that a function does. Always remember that. A function is just an input-output machine. Takes a value, does something to it, gives you a new value. And we can represent those values on these graphs of the functions. But knowing these families of functions gives you an expectation about some of the behavior of the function. That's eventually where you're going with pre-calculus and further into calculus, which is the destination that a lot of math students end up in, and it's essentially the study of functions. So this is kind of in a bizarre way your first move towards calculus.